All right. Good morning, everyone. Welcome back to Comp 3350 Software Engineering. We're really rapidly approaching the end of our course. We're really rapidly approaching the end of our course. In terms of what's going to be happening in the next couple of weeks, the content is finished this week, so Thursday will be our last content class. There's a test a week from today. The test that we're going to be writing is like the second half of the course. So everything that was covered in the first test, unless there's something that's building on what we did in the first half of the course, you shouldn't expect it to be redone. So like, as an example, don't expect to write user stories on this test. I'm not going to ask you to do that again. You've already demonstrated that to me repeatedly. But everything that was not on the first test, you should expect to be possible to be on the second test. After that, the time for the course, this classroom is basically free. This is going to be a good workplace for you to meet if you want to meet with your teams. I'm going to be in this room. I will just be in this room during class time. And what I am going to do is I may be inviting some teams to come and have a meeting with me just to make sure that things are going okay, that we're moving forward, just because we have some time before the last iteration is due. But I'm not going to ask all teams. There's just unfortunately not enough time for me to meet with all teams. So you may get an email from me asking you to come to class and meet with me on those days that we have class times, but it's not for sure 100% guaranteed. Before we get into any material for today, does anyone have any questions about the course going forward? Okay, cool, good. There's one outstanding deliverable that's part of the final grade of this course, and that's the assignment. The assignment will be posted next week. It will be available next week. It's not a big assignment. It's not onerous. It's going to be basically what we're doing today with legacy software, this week with legacy software. You don't write any code. I'm really just looking for you to tell me about what you might do if you were to make changes to an existing piece of software using the strategies that we're talking about with legacy code. But this is an individual activity, so everybody does this on their own. So you should expect to see that next week. And then that's it. That's it. Yes, yay. All right, yeah, good. All right, so what I want to do today is I want to finish up system testing, and I want to do a little bit of like a compare and contrast with the different types of testing that we've got. So there's 5 different properties, I guess, of the different kinds of testing that we're doing that I want us to spend a little bit of time thinking about and making comparisons between the 3 types of testing. And then we'll leave testing behind. And we will move on to talking about legacy software. The purpose of talking about legacy software in this course is about software maintenance. As nice of an experience as it is for you to go through this exercise of let's create this vision for a project and then go through building that project, your reality is not likely to be that way for a while. You'll definitely get to do this in industry, but the reality is you're going to be put onto a project when you first get a job that's already started and working, and you're going to be possibly doing something that is like bug fixes on software that's been deployed for a long time. And the purpose of talking about legacy software here is to start thinking about that. So how do we make changes to existing software without breaking what's already there? Okay, so quick recap here. System testing and acceptance tests are tests that are written by your users that reflect user stories and features, or epics. User stories are, again, this structure of, as a type of person who's using your application, some category of person that's using your application, I need to be able to accomplish some task that has been defined as part of this vision. The goal with system testing and the goal with acceptance testing is basically, I want to verify the second half of that sentence. I want to verify that the software that I have here, I am actually able to do that thing. I'm actually able to do that thing. We're trying to demonstrate that a user can actually do that thing. We did this last time. We went through the process of building this acceptance test. I need to stop and clarify terminology, sorry. I've been using acceptance test and system test interchangeably here. Acceptance test is like the plain English written version of this, the list of steps that we're going through, and the system test is where we are actually taking that list of instructions and putting it into code and making a code version of that. So here is the acceptance test that we wrote last time for Notflix. I'm not gonna like step through all the steps here, but the purpose of this is that we are going through the exercise of explicitly and comprehensively listing out what somebody would need to do. Somebody that's never used this application before. Here's a sheet of paper. Here's the app. Start doing this. Start going through the process of verifying that this behavior actually works in the system. And that person's job would basically be to take the app, open it up, go to step 1 here and log in. I'm going to type in Jeff and I'm going to type in Hunter2 for the password. That works. Check mark. I can move on to the next step. Check that I've logged in. I should see an icon on the screen somewhere right now. Oh, there it is. Check mark. I have logged in. I need to go to the upload page. It says click the plus button. Okay, there's a plus button somewhere on the screen. I'm going to tap that. I'm going to check that off. Now I want to expect a file dialog prompt. Oh, you know, I clicked on this button that I'm supposed to be clicking on to see this dialog prompt, and no, it didn't happen. So I'm going to stop testing. I, as a human, am going to stop testing this thing, and I'm going to write a bug report. Here are the steps that I went through to start trying to do this, and this is where I got stuck. This is the state that I got stuck in. When we're writing these acceptance tests, there are some assumptions that we have to make. Sorry, this is kind of a weird gray color. I'm going to see if I can make it change colors here. That didn't help. That didn't help. It says assumption. There are assumptions that we can make about the state of our application when we start. I don't want to write an acceptance test that is start by launching the system for the first time and creating a user account just to go through the process of verifying that uploading a video works. I want to try to isolate this little piece of behavior that I'm trying to test for this specific user story. So I'm going to make assumptions about the state of the app. A user account exists already. Somebody has gone through the process of making that user account. System tests, so when we go through the process of encoding this as code, they should be isolated in the same way that integration tests are isolated. The failure or success of one system test should not cause another test to fail or succeed. I shouldn't expect that the create user account, user story system test has run before this one has run. I should just say this data is already in the system, and when my test is finished, I should pull any data out that I've made changes to the system so that it's back in the same state that it was in the first place. The exercise that I would like you to do with your team right now is I want you to make an acceptance test. I'm going to scratch off for the Notflix user story. I want you, with your teams, to pick a user story in your own system. Like whip open GitLab, pull up an issue that is a user story that you have completed, and I want you to go through the process of making an acceptance test for that feature. The way that I want you to do this is first pick the user story that you're making the issue for, and then I want you to take this piece of paper and we're going to reuse the back of it. So I'm going to stick yours over here, fold it, stick it like this. I'm going to come around and I want you to write the user story that you've picked on a sticky note and stick it onto that piece of paper so everyone on your team can see it. I'm going to bring you markers, and I want you to write down the steps. What are you doing for this acceptance test to verify the behavior of this user story? So pick your user story. I'll come around and give you some sticky notes and markers, and then we'll get back together after that. Please go ahead. Okay, so what I'm going to ask you to do right now is I'm going to give you 2 more minutes. I'm going to give you 2 more minutes here. The 2 more minutes is basically take a capture of what you've got. Put it somewhere, like take a picture of it, take a screenshot, take a picture of it, and distribute it to your team, because ultimately you're going to be making these into system tests in your app. Just make sure that you've got a copy of this. Please take 2 minutes to do that, and then we're going to get back together, okay? There we go. All right. So the most common feedback I'm giving to teams is about the assumptions. It's about the assumptions. A lot of you have login as part of your test. One general piece of advice that I'm going to give you is to have a utilities class, some kind of a utilities class that does stuff like login and logout. From whatever the state is that you're in the app. If this is something that you're going to be constantly doing for every single acceptance test that you have, it will help simplify things. So like log in, do what you need to do, and then log out, and just have those methods as common things that you can call from all of the tests that you write. The other thing about the assumptions is being really explicit about what the assumptions are. And the goal here is that we're going to be taking this acceptance test and translating it into code. We're going to write code that does what this acceptance test says it's supposed to do. And in similar way to the integration test, where we're trying to isolate them from other tests, the assumption here is basically, I'm going to make a script file, an HSQLDB database, that has my assumptions in it for this test. And you might have the same assumptions for a lot of tests. Like you might always have Jeff and Hunter2 be the user and password that you're logging in with. And it's okay to reuse that same script file. But what we're trying to do is basically say, what is the insert statement that I have to put into this default script file for these tests? What do I actually have to put in my script file? And then when I run the tests, when I write the tests, what do I actually have to use to log in with? Because it's like a hashed password, so you can't even see what the password looks like in that database. All right, are there any general questions about acceptance tests? Good, okay. So when you are going through the process of changing your acceptance tests, rewriting them and coding them as system tests and code, you're just going to use JUnit. You're going to use JUnit. It's the same testing framework that you were using before. But you need a little more than that. You need that Espresso library, that library for simulating a human interaction with your device. So something that's going to click on buttons and type text. The library that I'm going to suggest that you use for this and what's in the sample project is called Espresso. This is a link if you want to click on that. And it's broken. It's a broken link. Don't click on that one. This link, that heavily documented by Google part, is a working link. I checked that before I came to class today. This is heavily documented by Google. And I think I'm going to put a link to this just right on the course webpage, so you don't have to go through the slides to find this link. It's really heavily documented by Google and the Android documentation. It's in the sample project. You have a sample for working with that. It works with JUnit, so you can use the same annotations that you've been using before, test, before, after, and then all of the assert, the primitive assert things, but Espresso provides other assertions that you can use for like checking that there's text on the screen, for example. And the goal is that you're going to take these handwritten instructions that you've written in your acceptance tests and write them out as code. There's one thing I want to show you specifically in this documentation. So it's fairly well documented. I want to point out this specific section here, test synchronization. So when you're interacting with your app in code, and when you are interacting with your app as a person, you're doing things that code isn't thinking of, like waiting for something to finish working. When there's a delay, so if you click on a button on your app and then there's a delay and you have to wait for something to appear, you have to encode that waiting action in the system tests that you write. So you have to go through this process of tap the button and then wait for something to appear, as opposed to tap the button and then immediately look to see if that thing's there, because it might not be there yet. This part of the documentation here will give you some ideas of how you can do that. One of the most simple brute force approaches is just do thread.sleep for 2 seconds after you click on something. But there are more robust ways to do that. So rather than just waiting around in a loop, you can actually have methods that are basically wait for this ID to appear on the page before you proceed with doing anything else. This documentation is well worth spending some time with when you are writing the system tests for your application. In terms of what you're doing for iteration 3 for this project, you're not required to write out the acceptance tests and then translate those to system tests. But if you're working together on something and someone is doing those acceptance or system tests for you, it might be worthwhile like working together to build at least one acceptance test to get a sense of what they're doing. If you're going to do that, you're more than welcome to use Post-it notes and giant sheets of paper. I'll bring them back with me next week. But one way that you can accomplish this is just to put comments in a GitLab issue. So the issue that you have for the user story, write a comment in there that describes what the acceptance test is for that specific feature. All right, good. That is the end of our acceptance and system testing discussion. The last thing that I want to do is just kind of a simple compare and contrast activity on the different kinds of testing. This is partly just a review because it's been so long since we've done unit testing in earnest. So I want to take the time to scale different properties of the different kinds of tests that we're working with. I want us to think about scope. So scope in this context, we're going to be looking at unit integration and system testing. Scope here is really narrow. It doesn't do much in terms of evaluating behavior, to very broad. It evaluates a lot of different things when it's running the test. Code coverage. So are we focusing on something that is situational? So like a very specific situation. We've got some very small thing that we're testing or something that we're testing a lot of different parts of our application, thorough coverage. Execution speed, they are really fast or they are really slow to execute the test itself. How often we would want to run those tests. And finally, the stability of the tests. Once I write this test, how likely is it that I need to change the test after I make more changes to my code base? So we're gonna keep working on this app. I'm gonna write a test for this thing. How likely is it that I have to actually change the test itself based on changes that I've made to the application? I want to do this in a Mentimeter. And what I want us to think about first is unit testing. I'd like you to do this as a team. So pick one person to have the device, and then you can talk about this. I'm going to leave this up for 2 minutes, and then I want to discuss unit testing on all these different attributes. Please go ahead. I'm going to give you 3 minutes so that you have time to like figure out your device. All right. Okay. So scope, I really agree with you. The scope of a unit test should be really small, really, really small, because we're really just looking at like tiny units of our code. Methods, maybe classes, but methods. Code coverage here. I see this is really contentious. We're kind of like smack dab in the middle. I am going to agree with this curve here, this curve of people that are saying code coverage should be quite high. I want to clarify what I mean by this. in aggregate, for all of the tests that we've written, the code coverage should be high. The coverage of one test will, of course, be very small because one single test should have a narrow scope. But when we write many, 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 many tests, the goal here is that we're trying to cover as much of our code base as possible with unit tests. So one single test has a really narrow scope, but all of the tests that we write, all of the unit tests that we write should have high coverage of the whole app, of the whole thing. The execution speed, I fully agree, these should be super fast. We're just testing one method. You know, integrating a mocking library and using reflection and stuff might make it slower, but like we're talking about nanoseconds slower. We're not talking about minutes and minutes and minutes. Because it should be very fast to run these unit tests, we probably want to run them fairly often, yes. We probably want to run them fairly often because it's fast to do it. It should be really, really cheap, so let's just run them as much as we want to run them. Stability of tests, I agree with. Once we write a unit test, because it's focused on such a narrow part of our code base, it's unlikely that we're going to have to change it. There are some kinds of unit tests that are fragile, that are more tightly coupled, and those are the ones where we're using that test spy pattern or the mock pattern, where we're trying to verify interactions between a system under test and its dependency. Black box testing, though, where we don't know anything about the internal workings of that code, it should be very stable. We're just depending and testing and evaluating the interface. Okay, good. Good. Are we good with that? Yes. Yes. Yeah. So yeah. So and I'm trying to, I want to clarify that. I want to make it clear that when I'm talking about scope, I'm talking about the scope of one individual unit test. And when I'm talking about coverage, it's the aggregate of all of the unit tests that we're writing. Yeah, so one single unit test, yeah, they're kind of opposites of each other, but it's because I'm trying to talk about two different things and clarify that, yeah. So scope here is just one single unit test. Code coverage is all of the unit tests, the whole suite that we've written. Does that make sense? Yeah. Good, thank you for that question. Okay, let's do the same thing, but for integration testing. This time I'm just gonna put 2 minutes on my timer. Please go ahead. Well, there's 14. I don't know why I'm waiting for my timer. Okay, great. I'm really honestly, very truly overjoyed that this is like right in the middle for everything here. A single integration test. The scope of this single integration test, yes, it's kind of in the middle because we're starting to go through the process of evaluating the behavior of our logic layer and how it works with the persistence layer, with a specific implementation of the persistence layer. So the scope now, it might be that you are calling one method, but more likely you're starting to call multiple methods on an interface to verify that that interaction works correctly. The code coverage, I'm leaning more towards this curve than this curve this time. We're going to be writing a bunch of integration tests, yes, but the coverage here is kind of more like what black box testing would look like for unit tests. An integration test really shouldn't know that much about the path that's beneath the method calls that it's making. It's just trying to evaluate the behavior between two things. This 3.5, it might be a little bit higher because you can start to write integration tests that do know about that implementation, but it's more like this. It's kind of closer to the middle. The execution speed, I mean, when I ran it on my laptop, it was really fast. But again, that's just because it's local. When we're starting to use things like an actual relational database server, the speed slows down quite a lot because we have to have an extra bunch of stuff. Because it takes more time to run, running them less often makes sense. Because we're writing tests that are highly coupled with the persistence layer in our case, as we make changes to our database, our tests might need to change because we're changing the schema of our database. So we might need to change our test to, handle those changes. We're changing our data model, so we have to make changes to the tests that we're writing for that. Okay, so this smack dab in the middle looks great to me. Are we okay with this? Any questions? Good. Let's do system testing. This is the last one. I'm going to put 1 minute, 30 seconds. All right. Scope. I fully agree with you. One test is like you click on a button and you're going through the entire architecture. From the start, the button click, all the way back to the database, back to the front end again to verify that something has shown up on the screen. The scope of a single test is really high. The code coverage, I kind of want to lean more toward this. It's more toward less code coverage. One single interaction on the front end is going to touch lots of parts. Yes, it's going to touch lots of parts. But a button press doesn't know anything about all of those edge cases that we're testing for in other places. So in the places where you're doing things like verifying that you have, I don't know, appropriate exceptions being thrown when you have a number that's negative in a place that you're expecting it to be positive, that's actually probably not something you're testing in a system or acceptance test. My advice to you, and what I'm telling you directly here, is when you're writing acceptance and system tests, this should be the happy path. The happy path meaning like, this is what I expect my user to do. This is not the right place for now, for us, for now in this course, to be testing all of your edge cases. Your edge cases should have been covered by your integration tests and your unit tests in this course. This is something that you might do in a job, go through the process of evaluating all those edge cases and making sure that your boxes are turning red and the border is slightly bigger and you know what to do. But our acceptance tests and our system tests are explicitly evaluating, as a person who uses this app, I want to be able to do this thing. It's not, I want to see the right error message when I put the wrong something in. So code coverage here is going to be trending toward the lower part of this. The execution speed, we're simulating people. We're going to be slightly faster, but we're still pressing buttons and waiting for stuff to happen. So the execution speed is fairly low. Because the execution speed is fairly low, the frequency of them, you just don't want to run them as often. You don't want to run them as often because sitting there and watching it, while it's thrilling to see your app doing stuff without you interacting with it, it's going to be really boring after a while to keep watching that. The stability of the tests is, yes, very low. You change the label on a button and now your test is broken. Maybe. You change the label on a text field that has your username in it and now your test is broken. Maybe. Every time you make changes to the UI, your tests might be broken and you might have to fix like finding the correct thing. Advice for getting around that is like try to find things by their identifier as opposed to by the text that's on them. So when you're using Espresso, you can ask for buttons by ID as opposed to the button that has this text on it. Try to ask for them by ID, and it's at least going to be a little bit more resilient to like moving buttons around on the screen or changing text on them. All right. Any questions about this? Okay, so here's what we've got. Unit testing, the scope of an individual test, pretty small, but in aggregate for all of the tests, we want to cover lots of our code base. They're very fast to run. We should run them really often, and they should be fairly stable once we've written them. An individual unit is not likely to change all that much. Integration testing, we're kind of squishing everything down into the middle. The scope is higher than unit tests because we're actually testing two different classes and how they work together. The code coverage is lower because we're starting to do more black box testing. We're trying to just evaluate how things are working together. The execution speed is slower. The frequency is slower because the execution speed is slower, and the stability of tests is a little bit lower because we have more coupling. System testing, the scope is really high for one individual thing. We start at a button, we click it, we go all the way through our architecture and back again. The coverage for all tests in aggregate should be smaller than what we have for our unit tests because we're just going to do happy path testing here. I am testing, I want to be able to do this thing, so I'm actually going to write a test that is just, I want to be able to do that thing, not I want to see errors for this. The execution speed is really low. Because we're simulating people, the frequency is equally low because it takes so long to run them, and the stability of our tests are lower because it is not going to be resilient to changes in our user interface because we're clicking on buttons and stuff and checking text. All right, cool. Thank you all for participating in that. We're leaving testing behind now. Testing is, that's the end of testing for our course. And what I want to move on to here is talking about legacy software. So as I said earlier in the class, you know, it really is great that you're having this opportunity to start a project from scratch and see it through to something that resembles what you originally came up with. But in reality, when you get out into a job in industry, it's not likely that you're going to be going through that exercise immediately when you start. But instead, you're going to be working on a project that already exists. Usually, when you start working on a project that already exists, it exists in some state. Maybe it has been deployed. Maybe it's been given to your client already, and they've been working with it for a long time. Maybe it has never been deployed. Maybe you're starting on this fairly early, but you're still not participating in the visioning activities that were started at the beginning of the project. Maybe this is something that was deployed to customers and then retired, but now it needs to be brought back for some reason, some business reason to bring this application back. Usually, when you go out into industry, you're working with professional software developers, and they make code that works. Maybe. Maybe it works. Maybe this has been put in deployment. Maybe it's in production right now. Yes, it works. Maybe it's not in production right now. Maybe it's been a while since it's been deployed, and the last time it got deployed was on Windows 7, and now it's being deployed on Windows 11, and stuff just doesn't compile or doesn't work anymore. Maybe it is currently being used in production. Maybe not. Maybe it's just been, mothballed for a while. Professional software developers definitely write documentation. Sometimes, maybe there's documentation for this. I mean, depending on the kind of place that you're working at IBM, there's lots of documentation. Working for a small startup, maybe there's less documentation than a lot. Yeah, actually, probably not. It has been worked on by many people, and this one is almost definitely, and not just like many people all at the same time, but many people over many years. This is something that might have been in production for a while, or maybe not, or it has been mothballed for a while. You have been given a job of I need you to fix this bug. I need you to build this for the current version of Windows or the current operating system that you're using. I need you to add a new feature. Before you can start hacking on that thing, we need to find some information about the project. We need to gather some information about the project and the state that it's in right now so that we can get started working on it before we do any of that hacking. The first question that you want to ask yourself is, what even is this software? What is it that I'm trying to work on? This is probably going to be told to you by a manager, like this is the job, this is what you're going to be doing. But you're getting that information. What is this software? What does it do? What is the purpose of this software? Who are the people that are currently using it, or who are the people that it is designed for? Who is a person that I can go talk to if something goes wrong with it? Who's a person that I can go talk to get more information about the bug or this feature that you're asking me to add? Who's worked on it before? Of the dev team, who has been involved in this project? If anyone's still around, can I talk to them? Can I get some insight about what's going on? Can I communicate with them? Do you have an email address for them? Where is their desk in this cubicle land that I'm working in right now? Once you have that information, how do you get this software? Is there a network file share that's got a zipped up folder of code? Does this shop use version control? What kind of version control software do they use? Do you have an account on that system? How do you get this code onto your own machine? How is the software organized? So specifically here, what I'm thinking about is what kind of an architecture does this software use? If it uses an architecture at all. Here's a piece of software. This has been around for a really long time, a really, really long time. I don't know what version of Windows this was introduced with, but the Microsoft Calculator has been part of Windows for a very long time. Microsoft released it recently in the last 5 years. They released the source code for the Microsoft Calculator, which is kind of amazing that Microsoft is doing anything like that. Good for them. Windows Calculator, a simple yet powerful calculator that ships with Windows. That's a nice vision statement. Here is the GitHub repository. Put a link to this on the course webpage. That text on the slide is a link. You can click on these links, or you can do a Google search for Microsoft Calculator source code, and you'll find yourself here. What is this software? Who's it intended for? Who are the original authors of this software? How do you get in touch with them? I don't want you to actually get in touch with them. I'm just trying to ask you to see how you would get in touch with them. I want you to look at the code, open up this GitHub page, and see if you can figure out if there is an architecture that might be documented. There might be a document on there that says, this is the architecture that we're using. Or alternatively, actually look at the code. Look at the folder structure of this code. What does it look like? Does it look anything like the architecture that you've been using so far? If you can, draw an architecture diagram to represent this. If you can, but you don't have to do that. And then finally, get the software onto your system. What do you need to do to get the source code for calc.exe on your system? If you're running Windows, you have calc.exe on your system right now, but how do you get the source code for this thing? I'm going to give you 5 minutes to start taking a look at this. The main things that I really want you to do are number 1 and the first half of number 2 here. If you can get to number 3, I mean, you've all done number 3. You've cloned repository before. You should know how to do that. The important parts of the first question and the first half of the second question. Take 5 minutes. Please go ahead. I think that what I'm going to ask is what you found for the first question here. So what the software is, I'm going to answer that question for all of us. It's a calculator. Who it's intended for? People who use Windows and need a calculator. Okay, good. Who are the original authors, and can you communicate with the original authors? I'm going to pull up my random number generator here, and I'm going to try not to generate Team 5 first. But I can't promise anything. The answer to these questions can be, we didn't find it, and that's completely okay. Just to be clear, there's like no shame here if you can't find it. It's not Team 5, it's Team 1. Randomly, Team 1 is the first one. Okay, so Team 1, were you able to find out who the original authors were of the source code? Bill Gates? Yeah. Okay.
There's like the contributors and everything on GitHub.
Okay. Even the contributors tab wouldn't necessarily be a good measurement of who the original authors are, because there have been decades of contributors to this. Yeah. If you can't find out who they are, then I guess you can't communicate with them. That's totally okay. That's totally okay if you don't know who they are. Even if you don't know who the original authors are in this case, can you communicate with people involved in the project right now?
Yeah.
And how do you do that?
Well, you can make a pull request.
Oh, yeah, okay. Make a pull request, create an issue in GitHub. Yeah. You can find the contributors list and you can go to their GitHub profile, and maybe there's an email address you can send an email to. Don't do that, but yes, yeah. Okay, good. Thank you, Team 1. Team three, were you able to identify an architecture for this app? Okay.
I just have to assume it's just the G tier with the presentation and a
Okay. That's okay. Thank you, Team 3. Team 13? Which is Team 13? The team that's not there. Okay. Team 7. It's all the odd numbers first. Team 7. Were you able to identify an architecture for this app? Okay. What did you find? Here, let me pull this up so we can all see it together. It's in Docs. And then application architecture right there. Okay. That's great. So this uses an architecture that we did not talk about in this course. You'll have to help me out here if you've taken HCI. You do MVC, but you don't do MVVM, right? Okay. MVVM is similar to MVC. It's similar to MVC in the idea that you have a model, you have a thing that you can view that model with, and then you have a controller that orchestrates everything between those two things. Model view model is a variation on that. It kind of makes sense that this application has an architecture that's like that. There's a domain model, which is really just numbers. That's the domain model for this application. There's a view. There's literally a screen that you're interacting with to change the state of the domain model. And then view model, I'm actually not 100% confident on this specific architecture. But view model, I'm guessing, is a way to bind those things together to work. Okay, good. Thank you, Team 7. Okay, great. This is good enough for now. The next part of this is basically, can you get this on your machine? And the way that you get this on your machine is to clone this. It's a Git repository. What I'm going to do now is start talking about this, and then we'll finish talking about legacy software next class. So I'm going to assume that you've got the code on your machine right now. You don't have to have it on your machine, but let's just say that in your workplace, you have made it to that point. You've got the code on your machine. Now you have to go through the process of figuring out if it actually works still. The first step you can ask is the build documented? So there's a nice docs folder here that describes some stuff about this application. The code that you're looking at for your specific thing, is this build documented? Is there a document in there that says somewhere how you get this app built? If the answer is yes, great, follow the instructions. If it's not documented, does it use language standard build tools? So if you're working with a Java desktop or Java web server application, does it use Maven? If you're using an Android application, does it use Gradle? If you're building a C program, does it use Make, or does it use like AutoConf? Or if you're using C++, does it use CMake or Ninja, or gosh, I don't know. If you're doing Python, does it use Poetry or pip or setup tools or whatever? If the answer is yes, well, then you sort of know how to do that, so build it. Use those tools to build it. If it's not, does it have an IDE config located in the software package itself? Is there something in this that's like a .idea folder or a .eclipse folder or a Visual Studio configuration file? I would advise generally against keeping these in version control repositories, but yeah, if it's there, open it in that specific IDE. If it's not, is this written in a language that you have used before? If yes, then try to build it with how you know about how to build programs in those specific languages. If not, then at that point, your options are basically, how do I build a project in this specific language? Oh, it did it for me. And then you start following the directions. This doesn't work. It doesn't work. Oh, man. Okay, so then what you would do, I'll demonstrate it live. You'd go to google.com. Then you type in, how do I build a project in Ruby? Okay. And oh, it's actually a nice little helpful box here that shows up. Great. After you've done all of that, can you build the software? If it's great, if you can, great. If not, well, then you go to a broken link and then you open Google and type in the actual thing that you're looking for here. Then you go to Google and then you paste it in. And then you hope for the best. Although ChatGPT can answer these questions now. Yeah, ChatGPT can answer these questions now. We're going to skip this activity. We are going to skip this activity because this kind of depends on you having Visual Studio proper installed on your machine. And that's a 40 gigabyte download, and I don't really want to waste anyone's time downloading Visual Studio to do that. With that, though, what I would like to do is skip over here. You should, at this point, be able to write acceptance tests, and you should be able to write and run system tests. You should be able to compare and contrast different kinds of tests. And at this point, you should be able to start describing how you would get information about legacy software projects. We will move on to how you would change legacy code in the next class. Thank you all for coming out, and I will see you on Thursday. Bye, everyone.